Let's build vanilla JavaScript 2D game completely from scratch. So this is level 1, shallow sunny sea. Level 2 is a dark, deep ocean. And for level 3, I did Hi coders, welcome to another episode of my creative coding series where we practice front-end web development techniques by building all different kinds of games, digital art projects and animations using just plain vanilla JavaScript and HTML5 canvas element from scratch with no libraries. You really liked my fish game we built in the previous episode, so let's add more features to it. As usual, I will explain every line of code as I write it, so feel free to code along with me and then you can share your projects and show me what you've built. I've been having a lot of fun creating custom distinct levels for this game. So this is level 1, shallow sunny sea, where we have to pop bubbles and avoid hungry sharks. Level 2 is a deep dark ocean with dangerous jellyfish. And for level 3, I did polluted sea overrun by humans. In level 3, humans have polluted the ocean and overfished it, so everything that's left is few sad fish and lots of seagulls that feed on leftovers. We are the last of our species and we are trying to survive by avoiding divers and fishing ships that are searching for us by shining light underwater. We can't stay in the light for too long or we will get caught. There is a little bit of subtext here because I am genuinely concerned about ever-increasing speed at which humans destroy nature. I had so much fun while building this game and practicing important vanilla JavaScript and HTML5 canvas techniques, and in this tutorial I want to share them with you. I asked you in a poll on my community page what features should I implement next, and your decision was clear. In this episode, I will show you how to add enemies for player to avoid and how to do repeating backgrounds. We will also cover a very simple way how to animate sprite sheets with multiple rows of images. Click the like please if you want more of this type of content. I noticed you really like building games with me, so I will try to make more of these tutorials in the future. If you are new to JavaScript and HTML Canvas, check out my playlists for beginners, where I handpicked easier tutorials which are great to prepare you for more complex and interesting projects. Have you made any games yourself? Put them on CodePen and share it in the video description. I will follow you on there. I asked you what should I call this game. Thank you for so many great suggestions. Let's dive deep into the code from where we left off last time and add more features to our vanilla JavaScript fish game. Have fun! So this is where we left off last time. We have a simple game here already. A player character that rotates and swims towards mouse when we click it, bubbles that rise to the surface, and whenever a player collides with a bubble, we get 1 point. In the last video, I gave you a challenge. Currently, when we resize browser window, the game doesn't register mouse position correctly anymore. Before we fix that issue with one line of code, let me temporarily comment out lines 135 and 137. We don't want to be listening to popping bubble sound this whole tutorial. So all I have to do to fix my issue with mouse position is to create event listener for resize event, and inside callback function I measure position of canvas from the edges of browser window, specifically distance of canvas from the top and left edge, same as we do on the first page load here on line 12. Once I know how far canvas is from top and left edge of browser window, we can use these values to offset mouse position and get the correct coordinates, like I did here on lines 20 and 21 in the previous episode. I will just copy canvas position equals to canvas.getBoundingRectangle and I paste it on line 163 inside the callback function on window resize event. Notice I didn't copy let keyword, just canvas position as variable name. This is because I don't want to declare a new variable, I just want to update the existing variable from line 12 with new canvas position values, so that it can be used correctly to calculate mouse position on lines 20 and 21. That's it. Now, when we resize browser window, mouse position is always correct. Challenge complete. In the first episode, I had this strange problem inside my custom handle bubbles function. When I run all this code inside one for loop that cycles through bubbles array, my bubbles were blinking. I resolved it by cycling through the same array twice, on line 123 and then again on line 127. This is not a good practice. We should be able to do everything while running through the array that holds our bubble particle objects once per animation frame. Thank you so much to everyone who contributed with their solutions in the comments. I think this comment from Radu summarizes the issue perfectly. Bubbles were blinking because when I splice one bubble from the array, because it moved past the top edge of canvas, or because that bubble collided with player, when I remove one bubble from the array, it changes index, variable I, for all the remaining bubbles in that array. Therefore, some of them blink because they get skipped for that one animation frame. You suggested multiple ways to fix this. First, I will move update and draw calls to the beginning of the loop to avoid this error we see right now. Now everything is inside the same for loop, and you can see bubbles are blinking whenever one of them gets spliced because it moved past the top edge of canvas or because it collided with player. To fix it, I can just adjust I variable by -1 every time I splice, to correct my index value for the missing bubble I have just removed from the array. I do that on line 128 for bubbles that moved past the top edge of canvas, and again on line 141 for bubbles that collided with player character. I can also clean up the code by replacing this if statement on line 130 that checks if that bubble still exists with a simple else if. This way this second block of code doesn't run for bubbles that were spliced in the first block. Time to add repeating backgrounds. On line 150 I create a constant variable I call background and I set it to new image. I set src on this background variable to background1png. You can download my simple repeating background I quickly created in Photoshop, or you can get a different one somewhere online. There are some nice free repeating backgrounds available on opengameart.org, for example. If you follow this series, you will know other places I use for sprites and in-game graphics as well. I create a custom function I call handleBackground. Inside I call ctx drawImage built-in method and I pass it background variable I created on line 150. I pass it the 0 for x, 0 for y, and canvas width and canvas height for width and height because I want this image to cover the entire browser window. Now I call my handleBackground function here on line 160 inside animation loop, and here we go. I created inverted background this time, where the background image is just the part above water. Canvas is still visible, so I can go to style CSS, and here on line 17 I give my canvas nice linear gradient background from top to bottom, between light blue, dark blue and black, for example. Back in script.js on line 10 I create a global variable I call gameSpeed. And I set it to 1. I want this variable to be global in case I want to increase game speed slowly as the game progresses. This variable needs to be available everywhere, so it can affect speed of anything in my program, if I want it to. On line 154 I create a constant variable called bg, background, and I set it equal to an object. I give it x property and I set it to 0. Now I can replace x position inside the draw image on line 160 to this variable, like this. Every time this function runs, I want to decrease x by 1, so you can see our background is sliding to the left. Perfect. I'm just doing the same thing I did for animated repeating background in my Flappy Bird tutorial. I rename x to x1, which will hold x coordinate for the first background image, and I create x2 for my secondary background image. x1 will start at 0, so here, and x2 will start at canvas width, so here. They will just be sitting next to each other and sliding to the left. Whenever one goes all the way to the left, it jumps behind the right edge so it can start sliding to the left again. Having two identical images sliding like this will create an illusion of endless repeating background. Y will be shared for both background images and it will be 0, so backgrounds are drawn all the way from the top. Width is canvas width and height is canvas height to make sure we cover the entire game area. On line 164 inside the draw image I change x to x1. I replace hard-coded 0 with bg.y variable from line 157 and I use my bg width and bg height variables here. When I change bgx to bgx1 on line 163, we can see everything is working. Then I say if bgx1 is less than minus bgwidth, which means if it has completely disappeared behind the left edge of canvas, set x1 to canvas width, which will push it behind the right edge, and it can start sliding to the left again. This is working, yes. Now I just need identical image that will fill this empty area. Its horizontal X position will be set to a different value from the first background so that it fills this empty space. So I just draw the same image, but I give it X2 instead, which means its starting position will be canvas width as we declared on line 156. Then I just copy lines 163 and 164 and do the same thing I did for my bgx1 variable. And this is how you create simple, endlessly scrolling background in your JavaScript game. On lines 163 and 165, I replace minus minus with minus equals game speed, which is a variable from line 10. Let's make the bubbles look nicer. On line 112, inside the draw method on bubble class, I call built-in drawImage method. Actually, first I have to bring the image to our project. I will use this free bubble animation from gamedeveloperstudio.com. This pack has 3 different animations I can choose from. I will download it and unpack it to my project folder. I will actually just take a single image that represents the first frame in the bubble pop-in animation. On line 89, I create a variable called bubble image and I set it equal to new image. Bubble image src will be name of the file I have just downloaded, so bubble pop frame 01.png. On line 115, I pass my bubble image variable to drawImage method. As the second argument, horizontal X position will be this.x from line 94 and vertical position is this.y from line 95. This way, I just placed the original provided image onto the canvas. I can see the image is way too big. drawImage method allows us to pass it optional 4th and 5th argument that take width and height. This allows us to scale the image to any size we need. I just pass it this.radius from line 96 for width and the same this.radius value for height. Now it's too small. Let's try this.radius times 2. That's better. Times 2.5. Get in there. I need to make sure bubble image is positioned exactly over the blue circle because that blue circle represents collision area between player and bubble. I can offset this.x and this.y like this. And this.y minus 60 as well. Minus 65. Slightly larger. Let's try radius times 2.6. Perfect. Make sure your images always match collision detection area as closely as possible, doing what I just did here. It looks good. I can now comment out code between lines 109 and 114. Let's create enemies. Well done if you are still coding with me. Click the like please if you want more JavaScript games. You can also subscribe, hit the bell icon and enable all notifications for my channel to make sure you don't miss any of my future creative coding tutorials. I bring a sprite sheet first. Constant enemy image is equal to new image. Enemy image src equals to enemy1 png. That sprite sheet doesn't exist, so I will just go to this site again and I will download this fish here. This one is completely free. You can also use any sprite sheet you want. In the next section, I will show you how to adjust your code to work with any sprite sheet of your choice. So I downloaded this swimming animation sprite sheet, I named it enemy1 and I placed it inside my project folder. I create a JavaScript class I call enemy. Constructor will have this.x property representing starting horizontal x coordinate. Enemy will be at this position when the game first loads. I will put it at first 200 pixels behind the right edge of canvas so that we as a player have a couple of seconds to escape. This.y vertical starting coordinate will be a random number between 0 and canvas height. Maybe with some edge from the top, because we don't want the fish to swim all the way up top above water. Let's see how these numbers work out. I might adjust them later. This dot radius will be 60. This dot speed will be a random number between 2 and 4. As you can see, our yellow fish is on multiline sprite sheet. Today I will show you a very simple spaghetti code version of code you can use to animate these. We will optimize it later as well. To navigate within a multiline sprite sheet, we will need some additional properties. This dot frame will start at 0. It will be a number between 0 and 12 because this particular sprite sheet has 12 frames. This dot frame x will be 0 at first, and it will cycle between 0, 1, 2, 3 because our sprite sheet has 4 columns. Frame y will also start at 0, and it will cycle between 0, 1, 2 because we have 3 rows here. Sprite width might be different for your sprite sheet if you are using a different one. Just take width of your entire sprite sheet image and divide it by the number of columns. So for me it's 1672 divided by 4, which is 418. Sprite height is height of the sprite sheet image divided by number of rows. In my case 1191 divided by 3, which is 397. So that's all for the constructor. We will use this to create an anime object, but we also have to give it some behavior with a draw and update custom methods. Draw method will just draw a red circle representing collision area for our anime, so that we can position sprite sheet correctly. Let's make it red. Begin path to start drawing shape. CTX arc to draw a circle. It expects X and Y position for coordinates. Radius, start angle will be 0, and end angle will be mass.pi times 2, which is a full circle in radians. CTX fill to actually fill the path with red color. Update method will take X and Y coordinates, speed and size, and it will update anime position for each frame of animation. I want the anime to swim from right to left, so this.x minus equals this.speed from line 184. If this.x is less than 0 minus this.radius times 2, meaning if anime disappeared entirely behind the left edge of canvas, I want to reset it back behind the right edge so it can swim through again. So this.x is canvas width plus 200. At that point I also want to give it new random vertical position so that it doesn't always follow the same path, and I might as well give it a different random speed to make it more unpredictable for the player. Now all I have to do is actually use this blueprint to create our first enemy. Constant enemy equals the new enemy. New keyword will trigger class constructor on line 181, and it will create one blank enemy object with properties and values based on blueprint we just wrote between lines 180 and 189. I create a custom function I call, for example, handle enemies, and here I just take enemy1 variable from line 206 and I call update and draw on it. To make sure this code runs for every frame of animation, I place this custom function here on line 219 inside the main animation loop. And here we go, we have a big red dangerous enemy swimming around. Let's use a sprite sheet. On line 196 inside custom draw method on enemy class, I call built-in drawImage method. It can accept 3, 5 or 9 arguments depending on how much control you want to have over the image. We have a sprite sheet we want to be cropping individual frames from, so I have to use the longest version with 9 arguments. The first argument is the image we want to draw, so I pass enemy image variable from line 176. Let me just show you the version with 5 arguments. So I just give it 4 destination properties, X, Y, width and height, to determine where on destination canvas I want to draw my image. This.x, this.y, and as both width and height I pass it this.radius from line 60. As you can see, it just takes the entire image, in my case a sprite sheet, and places that image at enemy's current X and Y coordinates, and it scales that image based on width and height we passed as the 4th and the 5th arguments. To actually crop out only a portion of that image, in my case we have 12 individual animation frames on that sprite sheet, we have to use drawImage method with 9 arguments. So the first is image we want to draw, Then we have source X, source Y, source width and source height that determine rectangular area we want to crop out from the original sprite sheet. We will be dynamically changing these values so that we crop out frame by frame and create animation. The last 4 arguments we already have here, this.x, this.y, this.radius for width and this.radius for height. These last 4 arguments will take that cropped out area and will place it at these coordinates on destination canvas. So as we do in every episode where we use sprites, source x is this.frameX from line 186, which will be 0 or 1 or 2 or 3 times sprite width. So when frame x is 0, we get this frame. When frame x is 1, we get this frame, and so on. For this to work, we also need to do the same thing for vertical y coordinate, which is similar. Frame y from line 186 times sprite height from line 189. Source width and source height simply determine how large the rectangular area we want to crop out is. We already calculated on lines 188 and 189 how big individual frames are, so I just pass these values here. There we go. Because frame X and frame Y are 0, we are always drawing just this frame, the first one in the top left corner. First of all, the fish is too small. Let's multiply the last 2 arguments that represent width and height times 2. That's better, but my radius on line 183 is set to 60, so when I pass the same value as width and height, I am slightly distorting my sprites. As we can see on lines 188 and 189, my frames are not a perfect square. Original width and height have different values. Let's just pass this.sprite width and this.sprite height here instead. Okay, that's too big, but at least now we have the correct ratio. Let's divide both width and height by, let's say, 4 to scale it down. You can see the fish is not exactly over the red circle. The red circle is important because it will represent collision detection area between enemy and player characters. So I have to make sure the fish sprite sheet image matches that collision detection area as closely as possible. I do that by manually adjusting destination X and destination Y values here. It's kind of trial and error here. I just try some values until I get it right. It depends a lot on shape of sprite image you are using. I'm happy with it now, so on line 181 I changed the starting X position of the enemy back to 200 pixels behind the right edge of canvas to give player an opportunity to avoid it. Up on line 8 I declared a variable called gameFrame. I initially set it to 0, and down here on line 223 in animation loop for every frame of our game I increased that variable by 1. I can use that to trigger anything periodically. For example, I can add power up every 500 frames or something like that. I can also use it to stagger sprite animation. Since the sprite has only 12 frames, it will be moving way too fast and the fish will wiggle too much. I can say only jump to the next frame inside sprite sheet every 5 frames of game animation, based on this gameFrame variable. Let me show you what I mean. I say if gameFrame percentage symbol used in if statement like this is so-called modulus or remainder operator. What I'm saying here is if gameFrame when divided by 5 leaves a remainder of 0, in other words, this if statement will be true every 5 frames, when gameFrame variable is 5, 10, 15, 20, 25 and so on. So every 5 loops of our main animation loop, increase this.frame on enemy class from line 185 by 1. In total, we have 12 frames, 4 per row on 3 rows. Now I will just show you a simple spaghetti code you can use to cycle through these multi-line sprite sheets. There is also a much cleaner way to write this code using, for example, modulus operator. If you know how to do this with less lines of code, let me know in the comments. So we start on frame 0, and frame X and frame Y also start on 0. Our sprite sheet has 12 frames, so I say if this.frame from line 185 is more or equal to 12, I set it back to 0, so we can cycle through it again. If this.frame is 3, or if this.frame is 7, or 11, that's these frames, because remember that I call this frame 0, not frame 1. When frame is 3 or 7 or 11, we want frame x to be 0, so whenever we get to the last column, we want to jump back to the first column again. If frame is any other value, increase frame x plus 1. So this is how we make sure frame x cycles horizontally between these 4 columns. How do we handle frame y? Modulus operator here seems like a good option. Do you know how that code would go? Let me show you a longer spaghetti version here for maximum clarity for beginners. So frame y variable from line 187, which is the vertical coordinate we use to crop out individual frames from the original sprite sheet, will be either 0 for the top row, 1 for the second row, or 2 for the bottom row. I will do if-else statement here to make sure the statements here are evaluated in this particular order. If this.frame, which cycles between 0 and 12, is less than 3, then this.frame y is 0, this first row. Else, if this.frame is less than 7, this.frame y is 1, that's for the second row. Else, if this.frame is less than 11, this.frame y is 2. It doesn't animate completely properly, which suggests I made a mistake somewhere. I don't see it right now. If you see it, let me know. I will fix that by creating a fallback else statement that sets frame y to 0. Now the animation looks alright. So this is so-called spaghetti, easily readable version of my code to cycle through a multiline sprite sheet. Every 5 frames of game frame variable, we increase this.frame on enemy object, which cycles between 0 and 12, and based on its current value, we adjust frame x and frame y to make sure we are on the correct column and row. These frame x and frame y variables are then used inside the drawImage method on enemy class to periodically crop out individual frames from my enemy sprite sheet, creating a swimming animation. Can you write a shorter version of this code that achieves the same thing? Let me know. How would you optimize it? This game is very easy now. The enemy doesn't actually do anything to the player. We need to make it dangerous. To check for collision detection between enemy and player, in this case I use, for example, collision detection between 2 circles, because both of them have a red circle that roughly matches where they are. I think for our purposes this is precise enough. As usual, to check if 2 circles collide, I need to calculate distance between their 2 center points and then compare that distance to radius of the first circle plus radius of the second circle. If the distance is smaller, we have collision. To calculate distance between 2 points on canvas, we create an imaginary right triangle between these 2 points. One side of that triangle will be distance between them on horizontal x-axis. So distance x is this.x, which represents the enemy because this is update method on enemy class, minus player x. Player variable is coming from here on line 85. It is an instance of my custom player class constructor I created in the beginning, so it has x property we can access globally by calling player.x. So now I compared the distance between enemy and player only on horizontal x-axis. I do the same for distance y, distance on vertical y-axis. Now we have 2 sides of imaginary right triangle. The right angle is here, and the distance between these 2 points is the hypotenuse, the longest side of the triangle, which is the opposite to the right angle. Since we know all this, we can easily calculate length of hypotenuse, therefore distance between these 2 points, by using Pythagorean theorem. The longest side of a triangle can be calculated from square root of adjacent side squared plus opposite side squared. In our case, math square root from dx times dx plus dy times dy. So now we know the distance between 2 center points of our circles, between enemy circle and player circle. If distance is less than this.radius, radius of enemy circle from line 183, plus radius of player circle, this will of course only work if player class has a radius property. If the distance is larger, they don't collide. If the distance is smaller, then there is a collision. If they collide, I run function I call, for example, handle game over. This function doesn't exist yet, so let's write it. function handle game over. Inside, I set fill style to white color. I use fill text, which expects 3 arguments. The text to write, so for example, let's say game over, you reach score, and I put the actual score value here. The second is horizontal X position, and the last is vertical Y position of where I want the text to be drawn on canvas. It works, as you can see, as long as I collide with the enemy, the text is there. It's kind of funny when the enemy swims away, game over text disappears and the game continues. We need to freeze the game when game over happens. So on line 236, I set game over to true. This variable doesn't exist yet, so up here on line 11, I create a global variable called game over, and I set it to false initially. Let's make the text smaller here on line 9. If they collide, this new game over variable is set to true on line 237, and inside animation loop I will check if game over is false. Exclamation mark means false. Only then run request animation frame and continue animating our game. If handle game over runs on line 234, it sets game over variable to true on line 237, and this if statement on line 251 will no longer evaluate to true and the game will freeze. That works. I can see the text is drawn under the enemy. On line 230, let's just swap draw and update. That should fix it. On line 236, I will adjust horizontal X coordinate of game over text to center it a bit better. We also no longer need circles under enemy and player that represent collision detection areas, so I comment out code between lines 193 and 196 on enemy class, and also code between lines 67 and 72 on player class. You can see the player is not animating, it is still showing only frame 00. Are you able to use the same technique we used to animate multiline sprite sheet of the enemy and apply it to player character? We have the multiline sprite sheet for that fish from the previous episode. All we need is the code that cycles through frame X and frame Y variables on player object. Click like please if you made it all the way through and had fun coding with me today. You can also check out my game development playlist in the video description down below. More tutorials like this one are coming soon. You can also follow me on Twitter or TikTok for previews of what projects I'm working on right now. See you there!